My name is Yoav Cohen. I'm from Perpetual Solutions, who is a training company, actually. Been working with SDOs for many years, especially MEFs, since 2002, I think. So I've been involved in a lot of the standard work that was going on there. And by the way, there is also track sessions on the MEF NF and SDN and NFV on Friday that is provided for those who actually wanted to register for that. So just that you know. Let's go on. So essentially, going on further with what the previous speakers talked about, what we see here is actually the network that is the basic framework and architecture for building all these services. So this has been designed and used and being evolving for many, many years. The ability for service providers to actually communicate and come together and be able to provide services across distances and beyond the immediate footprint that they have, serving customers that could be both residential, commercial, and mobile. So it doesn't really change the difference where those customers are located, as long as they can connect to the network, and especially at the connection point, which is the UNI. The service providers actually communicate through an interface which is called the ENNI, and that allows to hand off the information between them. And this is just a model because it allows to connect to data centers, to service centers that provide the actual services to the customers. And those service providers provide the communication capabilities to them. On top of that specific network framework come the actual services that Pascal already talked about. And what we see here is, first of all, the services which provide the actual connectivity, like the optical, which is a fairly newcomer to this model here. IP, I'll come back to Carrier Ethernet in a minute. IP as well, and those two, the specifications have been concluded recently. Carrier Ethernet for many, many years actually started by trying to bring Ethernet as a basic LAN and make it a service. And on that model, and I'll talk about that in more details, come the other two and try to leverage the actual framework that was defined for that. But Carrier Ethernet still keeps progressing, and features are added, new attributes are coming, and that is what is going to happen also to the optical solutions and IP. SD-WAN is, again, a newcomer. It's a new service, and MEF is actually trying to define what it is. I'll talk about optical and SD-WAN in a little bit more details in a minute. Security as a service and layer 4 to 7 in general are, again, things that MEF is working on in order to provide new services. All of them are laid across or on top of the basic networking architecture. So that's the basic foundation. And there is also a new group that is trying to look at the possibility to add new applications if and when service providers actually need those. On top of that needs to come the ability to manage the whole thing, and this is the LSO. So again, LSO is overlaid on top of this architecture and provides the same functionality to whatever transport there is. And again, I'll show you how this is done with the interfaces that the previous speakers already talked about. So going into a little bit more details on optical transport services in general, so we see here the actual architecture, which is currently at this stage is only for a single carrier. But again, the same type of interfaces are defined, UNIs. The same model of service is defined, although at this point it's fairly basic. So you can see here some of the definitions and attributes. But the same model that we use for carrier Ethernet is modeled also here in order to, again, allow the same basic management that would that nicely apply to layer 2 and to Ethernet being also provided here. So we already have a framework to manage new connectivity and new services. And specifically, at this point, the spec is only dealing with a basic service provider, but the idea is to enhance that to allow carriers to communicate together to provide services beyond the immediate footprint. And for that, there'll need to be also some kind of an in and I as a demarcation point between the services and an ability to sort of concatenate the service across several providers, ability to add dynamic services that like bandwidth and time slots that are currently fixed in this current spec and model, and ability to actually be a lot more flexible in the way the service would be provided to the customers. This is actually a proof of concept that was already tested and provided in recent MEF show. So what do we see here? Below we see 3 networks provided in this specific proof of concept by 2 companies, but they have their own controllers here. Okay, domain controllers. So that's the physical aspect. And on top of that, there is the LSO that also looks at the actual model of those 3 networks. On top of that, we see the actual service here. So let's take a simple scenario where we want to create a new service. So there is a request to add that specific service over here in this case. Okay, we don't see the actual request here, but going through the OSS, BSS, and all this process, it ends up in providing the orchestrator with the request for the new service with all the information that that service needs. The orchestrator, first step, needs to look at the network topology. So if it doesn't yet have it, it would pull it from the network. Once it understands the service, the network topology, it needs to take the service and actually break it into components so that he can feed each of the domain orchestrators with the requirements to add his component of the service and concatenate it together. So this would be those logical networks in the information model that the orchestrator has. Once it looked at that, and part of it is to translate now the service requirement to resource requirements that are needed to be passed on the Presto interface to the controllers over here. Once this is done, he feeds the controllers, each one of them, which is his part of the requirement for that specific service, and provide them the interfacing points that they need to interact. And they go and, through their interfaces, which is typically more proprietary, provide the actual configuration into the network. So that's the full model that we envision. And from that, hopefully, we can grow to this part that is missing currently in the specs to be able to provide that and provide it in a more dynamic manner. SD-WAN, yet another type of service. So that's the service model. Again, we start with modeling a service and then start overlaying on top of that the actual way to manage it. So the service model, the basic components for that specific service model are the UNIs, the demarcation point between the customers and the service provider who provides the service. And of course, the logical tunnel, which is here we termed it TVC, tunnel virtual connection, which they create in order to provide the customers with the connectivity they require. So those are the basic components for that network. And on top of that would be the service components and interfaces, which I'm going to talk about in the coming slides. So here you can see the actual components and the list of components. I won't go through all of them. What the upper part means is that we need the interfaces between the domain controllers that control the SD-WAN edges and gateway, and interface to the service orchestrator via the Presto interface. So that interface, again, comes into play also here, adapted to work with SD-WAN. And of course, the interface to the OSS/BSS here that allows customers to request a specific service. And finally, on the left-hand side are the basic components that we typically need to create a solution that is managed. So the Cantata and Allegro, which allow customers to request services and also monitor them dynamically. The Legato interface that allows an OSS/BSS to request a service from the orchestrator or the service orchestration functionality. This is where the translation between a service request and resources from the network are defined. And so he's the one that is responsible to break the service into components and request from each of the domain controllers, request to take responsibility on his part of the service. And the Presto interface is actually the interface that allows to request the actual resources from the domain controller. And the Adagio interface is the interface between the domain controller and the network elements in the network. Now, typically, if we go to the right side, this is where the MEF is concentrating on the components that he wants to define to support that in the case of SD-WAN. So we start with the self-service portal, but actually what's more important are these two interfaces, because the portal itself is not going to be defined by MEF, but we assume that those would be, at the end of the day, what the users would do. Interfacing to the OSS/BSS and the service orchestrator. So this is the we're concentrating on the service orchestrator to define the functionality that is needed specifically for SD-WAN. The Presto interface that, again, once the orchestrator decided what type of parameters and attributes are needed to request from the service here, that is what information that would pass through the Presto interface. And the Adagio interface is the connectivity to the network elements, which is typically proprietary and not defined by the MEF, but we do acknowledge that there are interfaces here, and so they appear here. What I wanted to, and I forgot to mention in the previous slide, I think, is that, no, not here. Actually, I want to go back a little bit here. That part of this work here is a collaboration between the MEF, ONF, and OIF, where in order to provide this interop and proof of concept, there was a need to collaborate with several SDOs. So MEF is not doing things alone. It's trying to work together. ONF was responsible to provide the actual basic Presto interface, which is based on TAPI, plus MEF extensions for the actual service definitions. This is where that collaboration occurred. And the OIF is the one that is defining a lot of the optical parameters and services, and he provided the actual specification and expertise to allow for this to be configured in the right manner. And I think I covered all the things that I wanted to. Thank you.